Absolute value and step functions. These are two very interesting functions that can be considered related to linear. So the absolute value function and the step function, we're going to start with the absolute value function. Okay, that one's just a little bit, simpler to work with to start. So the absolute value gives us a size or a magnitude of a number. So in other words, I like to think about the absolute value as the distance from zero. And that's probably what you've learned before as well. So if you think about a number line, the distance from zero, so a distance can never be negative. So the absolute value is never negative because it's a distance. So if we were to sort of buzz through some of these, what's the absolute value of -7? Meaning, what is the distance of -7 from 0 on a number line? It's 7. And what's the distance from -2 to 0 on the number line? The distance is 2 spaces. Same thing, what's the absolute value of 6? How far is 6 from 0? It's 6. And then how far is 0 from 0? It's 0. So that's easy enough. So now let's see what the absolute value function looks like on a graph. So let's consider this function f of x equals the absolute value of x. Sort of plain, not real exciting. We're going to call that the parent function. Okay, there's nothing fancy about it. It's in its most basic form. Okay, and as we go on this year, we're going to talk about some other functions, and we'll start with its most basic form, its parent function. So it says evaluate f of -7. So that means what is the absolute value of -7? We know that to be 7. So if my input is -7, my output is 7. Now what is f of 4? Absolute value of 4. And we know that to be, whoops, sorry, I didn't mean to grab that and move it. The absolute value of 4 is 4. So if I input a 4, I'm going to output a 4 from this absolute value function. It says fill out the table below over this interval. So it said this should be extremely quick. So in other words, remember, we're putting all these input values into this absolute value function. So if we think about it, these are all distances from 0. So you should start to see that pattern occur, that symmetry, around this point right here. And this is our vertex of our graph. We'll see what that looks like in just a second. So when I go and I plot these points, -3, 3, -2, 2, and -1, 1, 0, 0, you can start to see how quickly these are to graph. And it did say over this interval, but it didn't give us a specified domain. So let's go ahead and draw arrows and extend it beyond the 7 points that we've put on there. And let's absolutely label that with our parent function. So it says, what is the minimum value of this function on this interval? Well, right here, there's our minimum value. And what is that point? It's 0, 0. Over what domain is f of x increasing? So that keeps coming back to us. So it's increasing, or the slope is increasing on the right-hand side there. And remember, where it starts, it's neither increasing nor decreasing, so it's a parenthesis, and it continues on to infinity. Or we could say it's increasing for when x is greater than 0. So now let's get a little fancier with this function. So now we still have an absolute value function, and they want us to evaluate of f of 1. So if I put 1 in for x, -4. So if I sit and think about this in terms of steps, it's just like parentheses. Evaluate what's inside the absolute value first, and then continue on from there. So that's 3 plus 7. So my output is 10. Go ahead, flip the page. It says step functions are another type that are related to that linear family. And it says its graph will reflect its well-chosen name. You'll see why they're called step functions. Okay, it'll make a lot of sense. So it says, consider the step function given by f of x equals 2, and here's our domain, and f of x equals 6 under this domain. So it says, evaluate each of the following. After you do your evaluation, write down what coordinate must lie in the graph as a result of the calculation. Well, we're going to do this one in a different way. Let's graph it first, and then let's evaluate it. So let's think about this. How do I graph that 2? F of x equals 2. Well, this is what you did in previous night's homework. In other words, where does y equal 2? Okay, y equals 2 along this whole line here. Do we agree? But they only want this much of it, from 0 to 5. So where does x equal 0? So x is 0 right here at the origin, and go up and touch the graph, and it's 0 is less than or equal to. So less than or equal to is filled in. And it goes all the way up to, but not including 5. 1, 2, 3, 4, 5 go meet the graph, and it's less than. So less than is an open circle. So that's the piece of this function that I want to see. So I've got to get rid of all the rest of this here and there. That's just a little slice of that particular part of the function that I want to see. So now let's take the other piece. Where does f of x equal 6? 2, 4, 6. F of x equals 6 all along this whole line here. But what part of that green line do they want us to sort of demonstrate or showcase? They want us to show from 5 all the way up to 10. So the domain from 5 to 10. So 5 is less than or equal to. So that's going to be a filled in circle. So 1, 2, 3, 4, 5 go meet that graph, filled in, all the way up to 6, 7, 8, 9, 10. And 10 is less than or equal to, so that's filled in. So that, between those two green points, is the domain that they're asking for. So I'm going to erase everything else that's there. So we've got this nice little step function now. You can kind of see that it looks like steps or stairs. So now let's do some evaluating. F of 0. So if my x is 0, go meet the graph. What do we get? We get a 2. So that point would be 0, 2. What about f of 2? So when x is 2, go meet the graph. What point goes with that? What output is that? It's 2. So 2, 2. What about when f is 4? 1, 2, 3, 4, go meet the graph. And again, we get another output of 2. So that point is 4, 2. What about f of 5? So we end up with, let's see if, okay, still recording. Got a little nervous there. I thought I was just talking to no one. F of 5, so if that's my x, and I go to where x is 5, I've got this and this. But think about what this open circle means. It means that it's not equal to there, so it touches the graph way up here, which happens to be 6. So that point is 5, 6. And then what about when x is 7? Where does it meet the graph? Again, it meets it at 6. Starting to see a pattern here. 7, 6. And then what about when f of 10? F of 10 meets the graph up there again at 6. So that point is 10, 6. Graph the step function. We already did that. I just kind of flipped the order of things. Okay. So it says step functions can arise in the real world whenever the output to a particular function is constant over particular ranges. So here's an example. At a local amusement park, the park charges an admission based on age. Graph the amount of money a person would have to pay for admission based on their age. So here's a real life example of this. Remember that someone who is 1 day short of 4 years can consider themselves 3 and under. Okay, so 3 years and under are free. So it could be the day before your 4th birthday, and you are still going to be free. So if we think it's zero's right at this corner, 0, at 1 you're free, at 2 you're free, at 3 you're free, at 3.5 you're free, at 3 3/4 you're free, all the way up to, but not including the day you turn 4. Okay? So it's all of that filled in. Then 8 and under is $4. So the day you turn 4, you are going to have to pay $4. All the way up to, so 4, 5 years old, 6 years old, 7 years old, 8 years old, 8.5, 8 3/4, the day you turn 9. Okay? But, oh, I shouldn't say the day you turn 9 because that's going to change the price. So right until the day before you turn 9, you're going to pay $4. So we've done these two. Now 16 and under. So again, the day you turn 8, on your 8th birthday, you're going to have to pay $8. Fill it in. Okay? So the day you, on your 8th birthday, am I lying here? I think, oh no, I lied. No, on your 9th birthday, you're going to pay $8. So we've got 9, you're 10, 11, 12, 13, 14, 15, all the way up to 16, 16.5, 16 3/4. Oh, but on your 17th birthday, you're going to have to change that price. So therefore, it's not equal to, you don't pay $8 on your 17th birthday. You're going to have to jump up a price range, and you're going to pay $12. So 10, 11, 12 on your 17th birthday, and then to infinity, you're going to have to pay $12. Okay, so very practical application of that step function. All right, we're going to practice some more in class. We're going to do some other examples along with the homework.